Part A. Use the binomial expansion in ascending powers of x of 1 over the square root of 1 minus 2x to show that 2 plus 3x over the square root of 1 minus 2x is roughly equal to 2 plus 5x plus 6x squared, and the modulus of x, for the modulus of x is less than 1 half, 0.5. So we want to use the binomial expansion for this. So what is the binomial expansion of that, first of all, and then we'll think about how to use it. So, in order for me to expand this, first of all, let me remind you what the formula is for the binomial theorem. It is not that, it is that. That's your binomial theorem. You do get given in the formula booklet. So we need our expression to be in the form of 1 plus something to the power n, and then we can use that pattern of 1 plus nx plus n times n minus 1 over 1 times 2 times x squared, and so on, following that pattern. So, first thing, I need to write this in the form of 1 plus something to the power n. So this is the same thing as the square root means a power of a half, and I can move that to the numerator to be 1 minus 2x to the power of minus 1 half. So this is now in the form where I can use the binomial theorem. So let's create a bit of space and we'll do it. So my n is minus a half, and my x in this case is minus 2x. So we'll have, the first term is 1, then we'll have plus n times x plus n times n minus 1. So we've got minus a half, take away 1 is minus 3 over 2, divided by 2 times 1. And that's going to be multiplied by the x squared. And that's all I'm going to need here. Just looking about what I'm going to end up with, I only actually need to go up to the squared term. I don't need to include any other terms after that, so I'm going to stop at that point. But I am going to simplify this. So the 1, well, can't get any simpler than that. We've then got the minus a half times minus 2x. So that's just going to be plus x. We've then got the minus a half times the minus 3 over 2. So the two negatives will give me a positive. The 1 times the 3 is 3. The 2 times the 2 is 4. So 3 over 4. But then that's going to have to be divided by 2. So that's going to be 3 over 8. And then we're going to multiply that by minus 2x squared. So the minus 2x times minus 2x will be a plus 4x squared. There's then going to be a little bit more simplification because the 3 over 8 times 4 will become 3 over 2. So we have shown that this is the same thing as this. The question then is, how can I use that to help me with this? Well, first thing to note about this is I can think of this as being 2 plus 3x multiplied by 1 over the square root of 1 minus 2x. Hopefully you can see they are, the way I've written that is exactly the same, just longer. But the point is that this can be replaced with what I've just done down here. So I can say that 2 plus 3x is going to get multiplied by 1 plus x plus 3 over 2x squared. Right, so all I need to do now is expand this out. So we've got 2 times 1 is 2, we've then got 2 times x, and then 2 times 3 over 2x squared. We've then got 3x times 1, x times x, and I would also have a 3x times 3 over 2x squared, but that would give me an x cubed term, and notice we don't need to include an x cubed term, we only need to get to the x squared term, so I'm not going to bother writing that down. I am, however, going to do some simplification here, collecting up the like terms. The 2 is by itself, so we'll just copy that down. The 2x plus 3x is 5x. And the 3x squared plus 3x squared is 6x squared. And that's what we needed to show for part A. Right, let's look at part B. So it says to substitute 1 over 20 into this equation to obtain an approximation for root 10. So I'm going to substitute 1 over 20 in here, in here, in here, and in here. And hopefully I'll be able to see where this root 10 is going to come from. So first, let's focus on the left-hand side. Let's do 2 plus 3 times 1 over 20. Oh, 1 over 20. I think I was saying 1 over 10 before. 3 times 1 over 20. Add the 2 over the square root of 1 minus 2 times 1 over 20. So that's going to be 2 plus 3 over 20, 1 minus 2 over 20. So my numerator then is 23 over, so it's 43 over 20. 2 plus 3 over 20 is 43 over 20. My denominator there, the 1 minus 2 over 20, so that's the square root of 8 over 18 over 20, which I could simplify a little bit to be the square root of 9 over 10. Now the 9 square roots really easily, 10 doesn't, but that's fine. So the square root of 9 is 3, and then we've still got that root 10 there. Let's simplify this. So if we times top and bottom by the root, actually, probably easier, let's rewrite this as 43 over 20 divided by 3 over root 10. We can then use our usual rules for dividing fractions, which will be 43 root 10 over 60. So this is the left-hand side here. This is going to be 43 root 10 over 60. What's it going to be on the right-hand side? So if I substitute the 1 over 20 in then, so 2 plus 5 times 1 over 20 plus 6 times 1 over 20 squared. So just putting that into my calculator. I get 453 over 200. So we're saying that 43 root 10 over 60 is equal to 453 over 200. To get an approximation for root 10, I want to make root 10 the subject. So let's now times both sides by 60. And we'll divide both sides by 43. And so root 10 is equal to my approximate as a fraction in its simplest form is 1359 over 430.